Okay, hello everybody, and thanks for coming to this coffee lecture. So I'm an organic chemist. I spent my days programming, but many years ago, I did a software that maybe you know that is called XPreact that you are still using for ordering chemicals. And this is the stuff I did 35 years ago, so in 1989. So today I would like to present you something a little bit more modern. Oops, sorry. And there is this. And the idea is to be able to process NMR spectra directly in the browser. So we are used to install application to process NMR spectra. And the question is to know if we can just do it in the browser. And what we have now, and actually you may just go on nmrium.org and you will see exactly the same, everything will be live. You have a website where you can open and visualize and process NMR spectra without the need to install an application. So super practical with students, for example. And you can have it in the cloud. You go on this website. We could install it behind your firewall if you have private information. But if you are making research in the NMR field, we can also help you to add kind of plugins. You have a new algorithm for baseline correction, peak detection, or Fourier transform, or some new algorithms. We can help you to install it directly in this application. So the goal is to store as soon as possible the data in a database, and not only be able from any browser to retrieve the data, but also to analyze the data and save back the result in the database. And often it's an issue because the students, they have everything on their laptop, they leave the lab and you lose everything. So that was the theoretical part. Now, the practical one. So how it works? Well, if you go on this website, you can click on Start Now, and you maybe have some data. Here I have a JCAM file. It could be a broker file. I have a mol file. You drag, drop, release, and you open the spectrum in the browser. All the processing is done in the browser. So we reinvented the wheel and built all the Fourier transform, baseline correction, and so on in JavaScript so that it works in the browser. And in this case, what we can do is what we call the auto range picking. So the system will try to identify the multiplet. You can zoom in, you can visualize. This is very practical also for teaching. You have those hierarchy that you can display. You have the possibility to directly get the ACS assignment. So you can quickly copy paste this in a publication. And you can also assign the molecule directly in your browser. So we can let float this molecule. We can analyze the molecule and start to make links between what we call ranges and the peaks. So the system is aware of diastereotopicity. So for example, you can expand those two hydrogens here and you can start to assign the molecule. Once you did the assignment, you can maybe, okay, it's super simple, I know. So once you did the assignment, you can, if you want, display the numbers, and you will get the numbers at the level of the peaks and also in the molecule. Control C or Apple C, and you paste it in a new docs document. So that's how students could make efficiently reports. They just receive some data through emails. They just drop it in NMRium, they process, copy, paste, they get their report. So it's not only 1D that we can 1D after Fourier transform, but we can also actually make the full processing in the browser. So here I will just load an example. Here I have C13. So I have the FID. I will be able to make the apodization with a preview of the function that is applied on the FID. So you may display this function, you may display what you will obtain, and you may change the value of the line broadening. Once you apply this, you are able to make the Fourier transform. You can make the phase correction, or the 0, or the 1. Okay, apply. Can make some baseline correction. with a polynomial, and you get your spectrum. So as efficiently, you can open and visualize 2D spectra. So if I have a set of data on my hard disk, and here I have cyclosporine. Okay, you have some hierarchy, maybe you have some zip file, it's a little bit messy, doesn't matter. You drag, drop, release, and we will open all the spectra that are in this folder and group them per nuclei. So all the protons, 1D proton will be together, all the proton 2D will be together, all the proton carbon will be together. So in this case, we superimpose HSQC and HMBC. So you can quickly go from one to the other and start to analyze your data or assign your molecule. I will not do it now. Maybe you work with a lot of files, and working with a lot of files, for example, in the field of metabolomics, may be problematic. Well, a lot of files means that you may have something that looks, I will go back there, an empty NMRium. You have a data set like that. You play with Metabo. You have 50 samples. You do a lot of experiments. You're only interested in experiment 12. This is a folder that is relatively big. So we have 12,000 files, 4 GB of data, but we're only interested in experiment 12, and we want to compare them, analyze them. So what you can do is to take this folder, drag, drop, release. We will filter to open only experiment 12, and we just opened 77 1D files. So now you can start to process it. So maybe you want some integration. I will integrate this, for example, this, and maybe also integrate this peak. And I may sort all my sample per integration. Or I may maybe make a quantitative NMR and start to define the mathematical formula based on those areas to get the purity of my products, for example, or the conversion factor. So I can go there and create a new formula. Maybe my purity, it's the integration of A minus integration of B, those two zones, divided by integration of C. You may put any mathematical formula there. You may use log numbers if you want, and you will get your purity or your factor. And you may sort your spectra based on this factor. So with a couple of clicks, you can process a large amount of data. It's not an issue to have 100 spectra just with a drag and drop. You're also able to deal with reference database. Maybe you're working in the field of metabolomics, you would like HMDB, Human Metabolomics Database, and compare quickly spectra. Well, the idea is that you can load the spectrum, and you may have databases, and I have here an example containing databases. A database containing maybe Maybridge. So this is a set of 2,600 spectra that I just loaded in the browser. So I have now the list of 2,000 spectra. And with a mouse over, I will superimpose in green the reference spectrum. In this database of 2,600 spectra, what I can do now is to search. Maybe I would like that there is a peak up in this range. And I still have too many spectra with this range. What I can do is to make substructure search. Maybe I would like only the pyridids. On the fly, the system will search in the browser for all the spectra having a peak in the range 566 to 672, and also in the structure having a pyridid. Now, what you can also do with NMRium, it's teaching. First of all, it replaced somehow NMLDB that we did many years ago. You can draw a structure and predict spectra. But we will not only predict the proton, but we will also predict the carbon, the COSY, the HSQC, and HMBC. And it is interactive. So if the students go over, they will have the highlight in the molecule to find out between what and what is this signal in HMBC. If you are explaining to the student the second order effect, you are able to simulate perfectly up to 7, 8 nuclei. So for example, you have this AA prime, XX prime, super confusing for students. You have this kind of quadruplet in a doublet. Well, you may define, I have a paradise substituted aromatic ring, 2 proton at 7, 2 at 8. I have between the 2, 7 around 3 Hertz. I have 10 Hertz there, 10 Hertz there. And the system simulates this paradise substitute aromatic ring. And you may also show that it's not that interesting to have a gigahertz instrument, because you will still get this kind of quadruplet in the doublet. You cannot get rid of it. Finally, you may also give series of exercise, and I would be happy to help you to create your own series if you are teaching NMR. So you can send the link to the students, and those are exercises for structural elucidation. The students, they receive a molecular formula. They are able to make the integration. It's a kind of limited version so that they still learn something. You can define the sum of the integration, in this case, 6. They will analyze, okay, 1 there, 5 there, super easy. It's thiophenol. They will draw the chemical structure, and the system will tell them if it is correct or not. And they will do the next exercise. We are adding now new features that if they fail, there is some hints that help them to find the correct answer. I'm teaching to 200 students, and it's difficult to help them individually. So thanks to the hints, I hope that it will help them to learn NMR. Thanks for your attention.